Hello. So the PENCAST assignment that we're working on is from Homework 1, question 25. And it's a two-part question. So first we'll start with part A. And it says, how long does it take light to travel through a 3 millimeter thick piece of glass? Now, first to start this question, we should write down what we know. We know that the distance we want light to travel is 3 millimeters, and we'll represent that distance as x. Now we should convert this to meters to make it easier later on down the road. And we convert this by putting 1,000 millimeters at the bottom and 1 meter at the top. So our units can cancel. And this will give us 3 over 1,000 meters, which is the same as saying 3 times 10 to the negative 3 meters. We also know the speed of light, which is represented as c, and this is 3 times 10 to the 8th meters per second. We also know the index of refraction, which is represented as n, for the material glass, which is given in table 20.2. And this number tells us, this unitless number tells us how many times slower a light wave would be in this material glass. So, the equation that we're going to use to find the speed of light in this material is V material equals the speed of light over the index of refraction. Now let's plug all of our numbers that we know into this equation. Recall speed of light is 3 times 10 to the 8th meters over second, and the index of refraction for glass is 1.5. Now if we plug this into our calculator, times 10 to the 8th meters per second. Now the question asks, how long does it take for light to travel through this material? Which means we are trying to figure out time. An equation that we know with time is distance equals rate times time. And we want to figure out time. We can write distance as x, we can write rate as v of material, and then we can write time simply as time. And we know each of these numbers. We know x from above, and we know the v of material, which we just found earlier. And we want to figure out what time is. So we can isolate t, and it will give us this equation, x over v of material, which we'll simplify as v mat. Now if we plug these numbers in, 3 times 10 to the negative 3 meters over 2 times 10 to the 8th meters per second, and plug this into our calculator. We'll get 1.5 times 10 to the negative 11 seconds. Because remember, we're finding out t. The units for that is seconds. And our meters will cancel out. So all we have is seconds left. Now that we've figured part A, we can move on to part B. And it states, Through what thickness of water could light travel in the same amount of time? Now, let's first, again, start with what we know. We know from part A that we want it to be the same amount of time, as stated in the question. And we found that time is going to be 1.5 times 10 to the negative 11 seconds. We also know in the text in table 20.2, the index of refraction for water is 1.33. Again, we also know the speed of light is given, which is 3 times 10 to the 8th meters per second. And we want to figure out through what thickness of water could light travel. Therefore, we are trying to figure out what is x, the distance. So, the equation that we can use is x equals v of material times time. And this is the same as saying distance equals rate times time. And we know v of the material, we know time, but we want to figure out x. So we can simply plug in these numbers to figure out what x is. V of material, which we have an equation for, is, again, the speed of light over the index of refraction. In this case, the index of refraction for water. So now we can rewrite our equation as so. C over N water times the time. Now let's plug this all in. 3 times 10 to the 8th meters per second over 1.33 times the same amount of time that we found from part A, 1.5 times 10 to the negative 11 seconds. And if we plug this into our calculator, the answer for x will be 3.4 times 10 to the negative 3 meters. And this is the thickness of water the light could travel in the same amount of time that we found out from part A. And that is how you do homework number 1, question number 25.